Let us explore the fascinating idea of compounding, but not just for money. We often hear about compounding interest in finance, where your earnings generate their own earnings, leading to exponential growth. Think of it like this. Imagine you plant a seed. That seed grows into a plant, and that plant produces more seeds. If you plant those new seeds, you'll have even more plants next time. This is the essence of compounding, the idea that growth builds upon itself. While we commonly associate compounding with money, the principle extends far beyond just finances. Population growth is a prime example of compounding in action, even though we aren't talking about dollars and cents. Instead of money earning interest, we have people having children. Let's say a town starts with a population of 1,000 people. If this population grows at a rate of 2% per year, it doesn't just mean an addition of 20 people each year. It means something much more interesting. In the first year, a 2% growth on 1,000 people does indeed add 20 people, bringing the population to 1020. Now, for the second year, the growth rate of 2% is applied not to the original 1,000, but to the new population of 120. 2% of 1020 is roughly 24 people, which we can round to 20 or 21 people depending on how we are calculating it. This brings the population to approximately 1040 or 1041. Notice the subtle but important difference. In the first year, the growth was based on 1,000 people. In the second year, the growth was based on a larger number, 1,020. This is compounding in action. The growth in one period contributes to a larger base for growth in the next period. It's like a snowball rolling down a hill. It starts small, but as it rolls, it gathers more snow, becoming larger and larger, and therefore picking up even more snow at an accelerating rate. This compounding effect becomes much more pronounced over longer periods. If we continue with our town example, after 10 years of a consistent 2% growth rate, the population wouldn't just be 1,000 plus 10 times 20, which would be 1,200. Instead, due to compounding, the population would be significantly higher, closer to 1,219. After 50 years, that initial population of 1,000, growing at 2% compounded annually, would swell to over 2,700 people. That's more than double what a simple linear calculation would suggest. The rate of population growth, just like the interest rate in finance, is crucial. A small difference in the growth rate can lead to dramatically different outcomes over time because of compounding. A 1% growth rate compounded over 50 years will result in a much smaller population increase compared to a 2% growth rate over the same period. Of course, real-world population growth is more complex than a simple percentage. It is influenced by many factors like birth rates, death rates, migration, access to healthcare, economic conditions, and even environmental factors. These factors can fluctuate, causing the growth rate to speed up, slow down, or even become negative in some cases. Think of a garden. If conditions are perfect, plenty of sunlight, water, and nutrients, the plants will grow rapidly. But if there's a drought or a pest infestation, growth might slow down or even reverse. However, the fundamental principle of compounding still applies to population dynamics. The existing population, in general, is the base upon which future population growth is built. Understanding this compounding effect is essential for planning for the future. It helps us understand how quickly populations can change and the implications for resource management, infrastructure development, and environmental sustainability. Just like understanding compound interest is crucial for financial planning, understanding population compounding is crucial for societal planning. It highlights that even seemingly small growth rates, when sustained over time, can lead to significant changes in population size, shaping our communities and our world in profound ways.